And hello everybody, good evening, good afternoon, and good morning. Welcome on into the Dragon's Den. My name is Digital Dragon, aka Luke, and I am a 3D variety streamer here on Twitch. And so you may say, well, what does that mean? Well, it means that we do a variety of things that are 3D printing related here on the channel. We do everything from machine unboxings and assemblies like the Flying Bear Reborn 2 to mods, also like the Flying Bear Reborn 2. We've done full up system builds. This is a full up from the ground frame build, the whole 9 yards. This is a beta tested unit. We've also got kits or self-source kits for like borons that we've done. We've also taken part in some prototyping of the trad rack, as well as doing some prototype models for, or printing some prototype models for Free Heathen Workshop. So we do all kinds of things 3D related here on the channel. And one of the things that we've been working on over the last couple of streams is the Ender 3 to CoreXY conversion known as the EnderXY. So the EnderXY is a kit from Adativa 3D, and it enables you to take a basic stock Ender 3, whether it's an Ender 3, Ender 3 V2, Ender 3 Pro. Don't spend money on the latest and greatest because they've changed some of the things on the rails and stuff that may not be compatible, but any of the, I'll say the standard base Ender 3s. And converts it to a CoreXY platform, as you see here. Now my wiring has still not been completely tidied up. That's on me. You'll notice I still don't have the cover on here because, well, we can't leave well enough alone. As you can see, we are printing, and in this case, this particular print is starting to get a little fuzzy, right? We're starting to get a little bit of stringing. This has developed more and more over the last couple of days, and I'm probably going to chalk it up to the fact that we are right underneath a AC vent, and that filament is probably getting pretty saturated by now because it's been opened and sitting out for quite a while. So I probably just need to cook that in the filament dryer a little bit. Hey, welcome on in, Da Vinci and Pez Liz. How are you doing tonight, Pez? Or I should say Liz. So I have been printing, 6 of these at a time, and you'll notice I'm bending this a lot, and these are finally starting to pop off. This build tack is extremely well adhesion, it's extremely well adhesion, and I've got my first layer done right. It just really holds on. But I mean, if you look at that first layer, come on, camera. Come on, focus. You can do it.
Hello.
Well, if it'll focus, you will notice that that first layer, seriously, like focus. I don't know why it does not want to focus. Anyhow, if and when it will decide to focus, I really don't know. Like, me and this camera have a love-hate relationship. We're going to need to print the jig for like the proper focal length. But anyhow, it's printing very well. We are getting some artifacts from a cooling standpoint on the sides here, but nothing major. And definitely good quality enough to still do Toys for Tots. But like I said, my first layer is good. It's just this build tack surface is way too grippy. And so we're going to put a real flex plate on it and get that problem taken care of. The other thing we had talked about doing on stream is whether or not we want to stand with the standard system. So at this point, we've done the initial OEM upgrades. And somebody found the drop game. That is awesome, Da Vinci. Yes, please, please do the drop game. Here, I'll even get involved. So by upgrades, we, instead of installing just the standard hot end, we installed the H2 V2S Lite. So the kit itself comes with the V2S hot end. We went ahead, or I went ahead and bought the V2S Lite because I was interested to see how this goes. And I will tell you, in doing the racetrack pattern, I was getting flow rates on the straightaways of the racetrack pattern that was hitting like 40 millimeters cubed per second. And that was with a 0.4 nozzle. So I may have just gotten in a 0.6 hardened nozzle for this printer. Probably won't put that in on stream, but I will add this in later because I'm going to have to probably take a bunch of this stuff off to do that. I'm just going to be lazy and not do that part on stream. But the other thing that we don't have right now with our current board, so we did get the SKR Mini E3 board with this kit, which is one of the optional updates as well. So we got rid of the Creality board and put in the SKR Mini E3. Hey Chewy, how's it going, my friend? Welcome on in. But the downside of that is that means that even though I have dual Z stepper motors, they're still plugged into the same driver. So I can't do any type of Z tilt adjust, which will adjust it side to side to make sure it's flat and trimmed level with the hot end, right? So in order to do that, we can try and set it as close as we can manually, but we really need to have an extra stepper driver that we can plug the motor into. So we figured, I keep saying we, I figured why not just do the full Monty upgrade. So we have here a Big Tree Tech Manta E3EZ. A lot of words. What it means is the Manta line has the CB1 module. So this is their Raspberry Pi host computer module. It's comparable to, I'm going to say a CM3, not a CM4, right? It's the CB1 is really around like a Raspberry Pi 3B, not a 4, right? So this would be comparable to a Raspberry Pi CM3 module. We also will have 5 stepper drivers that I still need to install on the board. And this will run as your Raspberry Pi. And I will tell you that I've already got a full Klipper install on here. I've already got a printer config file done on here. And what I did was I took the base printer.config file for this board and just ported all of our printer config settings from here over, keeping the proper pin settings for this board. So when we go to make the cable swaps over, really what we're going to need to be looking for is pin alignment and compatibility. In other words, on this board, we may have, for the fan, it may be power than ground on the SKR, but on this board, it may be ground and power. We just need to double check that as we're doing our pin cut or our cable cutovers to make sure that we line them up in the proper place. Okay. This board also enables you to run the TMC 5160s stepper drivers, which means you can have high voltage in here. So you do have, let's see, we've got DC in, so this would be your 12 or 24 volt in. And you also have a separate input for the motor powers. So you have to provide either a jumper or a second set of connection wires over into the motors so that your motors get power. So this one powers the board and the CB1, and then this connection powers your motors. Okay? So we'll install this tonight. Now this can fit in this case, but it's extremely tight along the back row here. So what I did was I printed out a new case, and you'll notice that here would be the mounting lug for the front plate. So we're jutting out a good portion, but that would enable you to have better access to your Ethernet port, your USB ports, and then the USB to the actual, or excuse me, this is the HDMI port. And then this little slot right underneath your mounting lug is your SD card, right? All wires will go in through the back. And then you do have a wire slot on this side, which would normally be for your Z-axis motor to pop down or your Z Endstop. And then the other side would be to run your cable over. But it also has this little slot here. And what that little slot is for an FPC ribbon, so a flat ribbon connector for the BTT SPI display. Which, well, I have one of those here. So we'll be able to do a straight ClipperScreen on this, on the Manta board, right? And this is the TFT35 SPI. So the SPI display is purpose made for the CB1. I do not believe it will work with the standard Raspberry Pi. It is made specifically for the CB1, and you'll get the touch functionality. If you can plug this into a Raspberry Pi through the DSI cable, but it won't be a touch screen. It'll be just a Clipper display screen, which is kind of useless. So the motherboard is going to give us another stepper driver, which will enable us to run both Z motors on separate drivers, so we can do that Z tilt adjust to make sure that our bed is level across the plane where the lead screws are. To do that most effectively, though, you would need an auto bed leveling sensor. So we got a BLTouch, because remember when we printed off our fan shroud, we printed off the version that allows for a BLTouch on the side. So we will be adding a BLTouch to this, and I've got an appropriate type of length and cable from the EnderXY, which has like the extension and stuff. So we should have plenty of cable to make this work without having to go and buy a bunch of like a 1 meter or 1.5 or 2 meter cable or what have you. Let me take a moment. FedEx says no bamboo until tomorrow. Diggy darn dang it. That sucks. Now you got to wait a whole nother day. Hey, Timor, thank you for resubscribing for a total of 6 months. Thank you very much. Yeah, that really sucks. Hey, Shaudell, how are you doing? Welcome on in. Chewy's here. Papa Bear yelling at. We're going to get our coffee. And once again, we got our Tripod's Garage coffee cup. I just bought a new coffee cup last night from S-Rona, or was it S-Rona 58? So Shannon Rona. I just bought another coffee cup from there. How you doing, Stephen Poole and Abaddus? Welcome on in. Welcome on in. So yeah, in standard fashion, we built this, and I'm not going to say we built it stock. We built it initially with the OEM upgrade. So we never did put the Creality hot end on here, it's thrown into the creality bin in the closet. So if I ever need spare parts, or if I want to build like 7 recreators, I have enough hot ends and systems. I could probably build 7 of them by now with creality parts. But we're going to put a magnet on here, and we've got a KB-3D double-sided textured build plate that we'll put on this. We'll go ahead, and I had it on because it just finished a print today, and I did just remove the spool of filament that was on it. So that part's done. Everything's cooled back down. We're going to go ahead and do a shutdown on this. So we can power it down, because we're going to need to get in here and mess with the electronics. Okay, we'll power this down. We're going to disconnect this from the front. And I'm going to go ahead and just disconnect this for the time being. This is the this winds up being reused often enough. This is the Raspberry Pi 3B that I was using on my personal Ender 3 that I finally gave to Evil Diesel. But it's always a good one because it's a known working version that is always good to have around. So now I think what probably the best thing to do would be to, I'm going to undo the box and just slide the box backwards and out of the way, so that we can start by getting our new box mounted and get the board mounted down into the box. Now this box, it's got a pretty nice slide in top to it. I did get a little bit of warping on the edge here. This is Polymaker Draft PLA, which I really like the look of. It prints really well, and I like how it's kind of a matte finish, right? I do get a little bit of warping here. I could have combated that by adding Mickey ears or mouse ears to the corner, but I didn't. I wasn't too concerned about it. It's a case. A little bit of warping there isn't going to affect the functionality. Now, this is a spot for a 50-10 or a 50-15 fan. So this is a 50 millimeter. A 40-10 won't fit. So I don't actually have a fan that'll fit this, because I have 40-10s and I've got 60-10s and 60-15s and 60-20s, but I don't have any 50s other than the 50-15 blowers. And a 50-15 blower would be good. We'd face it down, so it'd suck air up from the bottom and shoot that air across. But I think that would be a little overkill, and we'll see. For right now, I'm going to go without a fan, and I will go ahead and get a fan on order from Amazon or something for this, and just go with a regular axial fan. So, and can everybody hear me okay? Because I was having some weirdness with my mic earlier. And I just want to make sure the volume is good for everybody. If somebody could just respond and let me know whether I'm blowing your ears out or not. All right, cool, Chewy, thanks. So I am going to take and put that off the table for the moment so I don't knock it over. Get some of these other pieces and parts out of the way. And like I said, I believe there is a screw on the bottom, and there is. So let me unplug this. I'm just going to put it on its side and take that lower screw out. That should be a 2 millimeter because it's a button head. Then we'll set it back upright, and actually, yeah, we'll set it back upright, and no, we'll just take this off because what I want to do is I just want to lay this in the back here so it'll be out of our way and we can move things from the back forward as we need to. Then we're going to reuse these same screws as we do this build. So how's everybody doing tonight? You guys working on anything fun? Doing any spooky Halloween prints or Toys for Tots or anything? Okay, so like I said, I'm just going to try and move this around the back so it's out of the way a bit. We'll set this back up. And let me go ahead and just take this off. And we'll have a spare screen that we can use if we ever need to. So I'll just set this aside. Now, I have seen people that have mounted this case at the back, which is totally doable. It could go in the front or it could go in the back. You just have to kind of make your decision. Now, if you go in the back here, you're not going to have that cutout here to route your cables through as easy. You'll have a very, instead of having a whole nice vertical path, you'll have a really small amount of space and you can come in through the side here. But it's up to you whether you want to mount it in the back or the front over here. The other thing is I printed out a mounting bracket, and once again, the draft did not really like dealing with the supports here, so I'm going to have to still work on cleaning that up some. But I could take this, mount it right in front as well, mount the screen right here. We're going to have, or should have, clearance. I'd have to validate that we have the clearance, and we would be good to go there. So we'd still have access to all of our ports, and this would be able to mount right there, and we'd have the full channel for our wires back there. So my plan is to mount this right here in the front, and this piece that I printed is being a pain in the tuchus. We'll mess with that later. So I'm just going to take my initial screws and screw this into place. Now it does have a lug over here to mount or slide into the Y rail, but I just went in with the slicer and added a couple of blocking, like a no print zones basically when I printed it out, so that it's nice and flush. And I also made it flush at the top so that once it's mounted and we get everything installed, we'll slide in our top and it'll have a nice, smooth, level appearance. So we might go ahead and install a, there's a couple things I can do. One, I'm going to go ahead and install probably a little bit longer screws in the front here. And I may, down the road, just drill a hole along the back, drill a hole back here or even under it. That will allow me to add a mounting point right against the rail here. And that will just give it a little bit more stability and rigidity. We'd probably have to go lower because the top rail would be right where this rib is. So we'd have to line it up with the lower rail. Go ahead and just drill 1 or 2 holes there and add a couple of M5x8 screws right there to hold it in place. And that'll make it a lot more rigid of a case. And I might just go ahead and do that in CAD afterwards and load it as a remix. But I do want to mount my board in here first. Now the nice thing is this is it is designed for an Ender 3. So all of the mounting holes are in the exact same places as an Ender 3. I'm going to take this out so I don't damage it. And we're going to go ahead and just sit this down on top of the little bosses. And we're going to, when we screw it in, we're going to screw it directly into the plastic. And you have to make sure that all of your openings, that all your slots line up and that you're properly lined up on your holes. So you just basically make sure there's something light behind it so you can make sure that your holes are lined up. And then we'll go in with some M3x6 button head screws and install that down. And I'm just going to use mine here. Awesome, Papa Bear Yelnats. So Papa Bear, are you actually running Marlin still, or are you running Klipper? Okay. Yeah, it feels like it's going in, but just really slow. You will be cutting your own threads, so I did triple or quadruple check that it did say that these were M3 screws. Just for giggles, I will try an M2.5x6 just to see if that will actually thread easier. It could just be that my hole tolerance sucks on this print for whatever reason, but we'll see. Yeah, the 2.5x6s actually thread a lot easier, so we'll take this M3x6 out. Darn it. All right, miss that in a second. Everything you did on Klipper made messy prints. Yeah, I mean, Klipper is good, but it's not the panacea. You still have to, especially on something like an SV06, where you may have good support and the manufacturer provides the needed information. Otherwise, you have to know how to derive a lot of the information for all of your your E-steps, especially for your extruder, and a lot of tuning in and stuff. And if you stay with the firmware that's provided by your vendor, you know, it's all kind of there. And the SV06 is really, you know, everything I've read, once again, I don't have one, but my understanding is they're pretty darn good stock from the factory. All right, this is weird. So it easily turns. It doesn't feel like it's backing out, but it does feel like it's somehow stuck on there. This is weird. Yeah, I tried going to Klipper on my Prusa Mark IIIs that I converted over to Bears, and for whatever reason, I like you were having, I couldn't get them to print worth a damn consistently, and you know, I was using like SKR 1.4 boards or stuff like that, and I just could not get the right settings in Klipper to make it work right. So, oh, there we go. It sheared off a tiny bit of the print. So it's more like we just need to get it through the little bit of plastic it took off. 3x6, 3x6, well, 2.5x6. Then 3x6 it's fallen to the ground. And so yeah, I wound up like, okay, I'll just give up on this. I went back and I put all I did, no physical changes whatsoever. I just went back and put the EnderXY board in them. Went ahead and bought EnderXY boards. They weren't even from Prusa themselves. I bought them, you know, other places. Put an EnderXY board in it, put Prusa firmware on it, and rock solid prints. So something like a Prusa or something where the manufacturer has actually spent a little bit of time tuning it, it's just so much easier to stay on their stuff because it works. Unless you've got, I'll say, the proverbial lemon that just really, really sucks, stick with it. And my preference, and this is why we did the Flying Bear the way we did, is because I had zero knowledge of the Flying Bear. And so with the Flying Bear, we built it stock, right? Hey, welcome on in, Creatix Brit. How are you doing this evening? Hope you're making some progress on protecting your identity stuff and shutting down some cards and everything. And hopefully that whole scenario works itself out. Okay, so we used our M2.5 by 6mm screws. And we've got that in, and that board's nice and solid now. We'll do our routing, and then we'll just kind of lay our antenna on top. There's really no, I mean, if you want, you can kind of pull it out and move it around somewhere, but I'm normally good with leaving it where it's at. the other thing I need to do before we go too much further is open up my package of drivers and get my driver boards installed. And I have never used the EZ drivers, so this will be something new. There we go. And I just went ahead and got a package of the 2209 TMC drivers that go with it. And there's only one way that these will slot in, which will be interesting because now I've got to figure out that way. Okay, it probably would have been easier to show you, but on the board, on this side, there's a little cutout on the, you can see that little cutout there? On your board, you've got this little notch on one side, and that's going to slide into that cutout so that everything will line up. You just push it on there. And these are cool because each one has a nice little heatsink package on it. Both sides are attached. It's a single aluminum heatsink around the edge. And you do have the ability to set the voltage on these. And I do have it all set to 24 volt or VN power at the moment. I didn't hear that one clip. There we go. Really putting in memory sticks, just about as much fun. Like, I don't know how much pressure to apply or if I'm going to snap something in the process. There we go. Okay, so we have all 5 of our EZ drivers installed now. And by the way, on our connections, we're X, Y, Z1, Z2, which we won't populate, then E0 and E1, and we will populate the E1 with the second Z motor. But first, we're going to need to pull up our handy dandy wiring diagram so we know how to do all of our various pinouts down here so that we can move all of our cables over as appropriate. We decided we were going to use a little bit larger button head cap screws here. These are in 5x8s. I've got some 10s here, but let me go grab ones that are slightly longer. Don't need to be really long. I'll grab some M5x14s. Just give us a little more bite in there. And especially if we decide to put the screen mount there, it'll also give us the ability to, go through that additional layer of material. Yeah, I do that throughout the day sometimes. I am getting to that stage where, midday naps are kind of good. We call it lunch, but, I rest my eyes a little bit during lunch. So you see how that's yeah. You see how that's kind of a bit floppy? And that's what I'm saying. I'll identify where to make 2 holes. I'll drill 2 holes through here, and then I'll just add some blind nuts back there and some M5x8s to hold it in the back. And that'll help snug that back up. So you'll have, 2 in the front and 2 in the back, and this whole thing will become rock solid then. So, but now what we're going to do is I'm going to snip my little, I'm going to snip my one zip tie that I put in here. And just a zip tie, no wires, no whammies. And then one by one, we're going to take wire from point A and move it to point B, which means it'll be good to have the wiring diagram for our SKR Mini E3 V3, as well as a wiring diagram for our other board. Let me just make this a little bit bigger for myself and my old man eyes. Color codes are great, but only sometimes. Hey, Shenanigans, welcome on in. The helmet is on the ground. Oh yeah, there's a couple of helmets on the ground. There's like 4 or 5 helmets over there in the corner. It's all good. I'm going to actually put that one together, and I may paint it. May send one to, or take one to Rocky Mountain for me or with me and give it to Free Heathen because he loves the Death Angels. Okay, and so let's change up the view here. Get the browser view, which is not set to the right window, so let me fix that. There we go. So this is our little diagram down here, and this is straight from the manual, which you can go and get off of GitHub, github.com under Big Tree Tech. And so, like I said, all we're going to do is we're going to take one wire at a time. We're going to move it over, and when we do, we're going to make sure that anything that's polarity sensitive gets put in the right polarity. And then again, the other things would be like even on your end stops, because we have our end stops and everything was working on the other board, we need to make sure that even though the end stop would work with, say like ground and PC4, we need to make sure that those are in the right order, that the signal pin is in the right slot, so to speak. Otherwise, we can actually get the reverse for our end stops, which isn't necessarily like it's not going to end the world, but it just means one less thing that we'll have to check for from a software standpoint when we got to run the software side of things. What I am going to do right now is I'm just going to unplug all of the, I'll say the power wires for like the bed, the power in, and the heater wire, because those are pretty much the shortest wires of the bunch right now. So by getting those out of the way, that should allow me to bring this around pretty much to anywhere I want and make it easier to do a little bit more of a side-by-side here. Power wire, power wire. That's the it's a bed thermistor. Okay, let me do that. Do that. I can bring this over here. Okay. So what do we want to start off with? Let's start off with, we'll just go from the front back. So we're going to go with thermistors. So the first wire we have here is thermistor 0. We're going to pop that off. Maybe. Pull that out. Always got to be one. There we go. And the way this is connected in, it's ground, then the PAO, which is the signal pin for it. So when we come over to our chart and we find where our thermistors are at, so the thermistors are right up above the connector here for our screen, our standard screen. So we're looking for T0. TH0 would be the middle of the 3 pins, and it goes signal pin at the top, ground on the bottom, which does line up with the correct orientation that we've got here. So we're going to be bringing this in. See about getting some of my wires a little bit organized. Well, we're just going to bring this under our outer leg here and then right through the tunnel. And we're going to plug that in. Right like that. Next up will be our bed thermistor. And the bed thermistor will be the one just forward of the one we just did. And I should probably bring you guys down onto the table, huh? Yeah, let's do that. Let's bring you guys down on the table so that you're close in and personal as we're doing this wiring here. I'm going to do this. I'm just going to stack a couple of boxes up to make a platform to set you guys down on there. I raise you up just a tad bit more. Good thing my Amazon guys like me and bring me plenty of boxes. Yep. And now I'm just going to wind up grabbing the stand because I'm going to need to angle you guys down, and I'm not going to get a good enough angle that way. So sorry about that. We're going to move you around a bit again. That down there, that down there. Okay, that works pretty good. That's almost like a top-down view. So we've got our initial thermistor in here for our hot end. We're going to need to bring in a thermistor for our bed. And once again, once I get this wiring sort of figured out, I am probably going to come in here off stream and just redo all of the wiring completely. Like for the bed, I am most likely going, if I keep this bed and I don't go and put like a new Mic 6 bed on it with a silicone heater, I'm going to dismount the bed and take off the stock wiring because I really don't like having a either Wagos or something else on the bed wiring there. And I will just make one single long cable from the bed directly down to the board, and do some wiring strategy like that versus, having a couple of jank connectors in there. And looking at this, let me see what we got. We have heated bed on this first connector here. So I guess while we're here, we'll go ahead and we will route the heated bed in there and get that plugged in. Ground is towards this side, and then so we'll have ground and then positive. So we'll bring this in through our little tunnel. And really, I'm just going to do these now because I was going to hold off and do these at the end, but I think as I get more and more wires here, it'll just be more and more wires and I'll have to get out of the way to do this. I'm just opening these connections up, and then I'm going to bring in my 2 wires. And there's kind of like a separate trough on this side that we can run our wires through. It would probably be so much better if they hadn't shrink wrapped the wires together. Or it probably would have been a little bit easier to work with had I not mounted the board yet, too. Okay. I'm just going to peel back some of that shrink wrap to make it a little bit easier to move these wires around. Hey, 3D Medic Vince, welcome on in. Mod Light, welcome back in. Didn't have a problem with the video other than I was moving the camera around and you can hear my voice, but you can't see my face because I don't have my face on the screen right now. Once again, all I'm doing is I'm just peeling back some of this shrink wrap so that I can get these wires to move a little bit easier so I can route them in here. So what we're doing, Mod Light, is I decided to install the this is the BTT Manta E3EZ board, and I've decided to install this so that it will let me run independent stepper drivers for my Z motors, which will allow me to run things like Z tilt adjust. Where are my pliers? I might just, yeah, I'm just going to bite the bullet and pull the board back out. I'm just fighting with the with space constraints right now. So I've already offline, I plugged this board in using a wall wart to provide power. And I have the CB1 module configured, so it's got a full mainsail implementation on it. Basically what I did was I took and installed the minimal image on it because I don't want their version of Klipper. I wanted the vanilla image. So I did a vanilla image of the operating system, minimal OS install. Then I did updates. And then I installed Kaya and ran through the Kaya install and upgrade process to get all of the components installed. Now what I'm going to go through and do is install all of the wiring properly. And what this will give us is, this is a 5-stepper board, a true 5-stepper board. So that will allow us to run our Z motors on independent steppers and allow for things like Z tilt adjust. So we'll be able to get our bed level or trimmed to the hot end at the lead screw points. So that way we'll that way I can get these wires to line up down there. There we go. What we'll be able to do is get a truer bed tram, and everything will work a little bit nicer for us. And I'm also going to add a couple of holes in the back for this mount because, as you see, this wiggles way too much. So I'll just off stream, I'll find a spot, drill holes, and we'll get a couple of screws in the back there that will help hold things a little bit tighter and keep the board from flopping around. And we'll also add, like I said, this is a 50 size fan opening, and I do not have any 50 axial fans. And unfortunately, I do, well, not unfortunately, but I do have some 50-15 blower fans, but one, that would be overkill, and two, it would make a racket because it would be an always on type of fan, or at least one that we would kick on based on a temperature of the CPU. One there, where's the other one at? There's one there. All right, I'm trying to keep my hand out of the way, but I'm righty, so now I'm trying to do this left-handed so you guys can see. And then, what board were you using, Modlite? A decoding issue on Twitch side? Okay. Well, I see no dropped frames yet on my side, so that's actually good for my stream. 1, 2, 3. Where's the fourth one at? Oh, there it is. That's right. You were using a Big Tree Tech board, but the Tri-Gorilla, the default board. Which Big Tree Tech board were you using again? So the next one in line is our Z Endstop. And funny enough, we have our Z Endstop. We just plugged it in the way it was. Really? All right, so this is our Z Endstop. We'll slide this down and around. And where are our end stops? Well, our end stop and people. Oh, okay, gotcha. So XYZ, they're 2-pin end stops, and they are signal, then ground. So signal, then ground. And they're backwards. So they are backwards from what we have on this board. And that's why we need to check those out and pay attention. So these connectors, the left side of the connector is ground. The right side of the connector is the signal pin. On this board, it's signal pin on the left and ground on the right, or in this case, in the orientation for me, signal on the bottom, ground on the top. So I need to rotate these pins, or I need to remember to go in and change my config. And I would very much rather just rotate the pins and not have to worry about changing the config, because I've already got the config. I basically took the config from the SKR Mini E3 V3 and mapped it over to the config on the SKR or the Manta E3EZ board. So that config file has already been created, and I don't really want to go and redo it. So it's going to be easier just to swap the pins around while I'm playing with the wiring. So and this once again was the Z end stop. So it's going to go on the right side here, or the right. Yeah, you're all. So this is Z, Y, and then X. So the next end stop we'll have to play with will be Y. Once again, we're going to swap these wires around. So it's simply putting the tip of a needle, or in this case, tweezers. So we push that pin down, give it a tug out. Whoops. Yep. Then do it for the other side. Sorry, mod light. I was not looking at the things. So shenanigans. This is, whoops, that was great. I just popped the connector off, so we'll be redoing a pin. Yay! Just what I wanted to do today. All right. Give me a second to go grab my crimping stuff. And let me get caught up on chat here real fast. So, taking a lot of fan ports out on a Big Tree Tech Octopus board. Yeah, you got to make sure that they're set to the right voltage, and then that you're plugging them in the right polarity. It can be a pain in the butt. Not there. Do I have a shoe pin in there? Of course I don't. That would make it too easy. It was there. Now I'm just going to swap over to a different pin because that is going to make life easy. Okay, and case in point, so we're going into Y next. So my X is here, my Y is here. Both of these come around down this pillar, which means this would be my Y, and the one I actually ripped the connector pin off of is the X. So let's see if we can't get this one undone. Yeah, the SKR EZ, I haven't looked at all the specs on that one yet, but I don't see why they'd be too dramatically different. The difference is, of course, they've got the EZ boards versus the standard steppers. So you'll have to get the EZ boards, or if you've already got them, then that's definitely another selling point for getting the EZ version. Okay. I'm going to bring this one around, and this is going to go into the Y connector. And then our X Endstop would be the one that we are, where the hell, there it is, that we need to fix one of the connectors on. It figures the one connector head that I knock on the floor is the one that I actually needed. Okay, so we're going, black's got a good connector on it, and that's going to go on the right side, and that side. We need to just recrimp a connector on here, which I did just pop one off. Yes, I already did that. Sorry, yes, I've already commented out any of the ADXL virtual MCU stuff. Yeah, if you're going to go to a different board, there is, yeah, if you're wanting to use stock firmware on your printer, you're going to have to buy the same board, unless your vendor has already provided, you know, different firmware for a different board, which I doubt that they would do that. Okay, that's a good crimp. Slide that in there. And this is coming from our cable chain up top. So this is going to definitely be our Endstop. So Z, Y, X will go down here. Okay, now we're going to have our fans, and I do believe I set the fans up to be in the exact same way. So this is fan 1, this is fan 0. Fan 0 will go into fan 0 up here, or fan 1, or whatever the first fan is. So I'm going to unplug that. Bring this under and around. Definitely going to have to clean up this wiring. But that's Future Loop's problem because, like I said, we're going to fix all this wiring up once we get the new board and we got everything decided where we want it, and then we'll make it nice and pretty. So our fans are signal pen. So these are our 3 fan connectors right here. And the signal pen is on the side where my finger is, and the voltage is on the side towards the motors. So yeah, so positive is on this side towards the motors, which means, of course, these need to be flipped and rotated as well. So See if we can get these off without ripping one of the connectors off the cable. Okay, so that's how we want this now, with a positive on this side, negative on this side, so that we can plug it in. So this was fan 0, which is going to go in fan 0 here, which is the one closest to the main power connectors. Oh, I hate life, because for whatever reason, all the other ones, the opening is this way, and on this one, the opening is the other way. So now I get to pop this back around, since the connector goes physically in the opposite direction as all the other ones I put on so far. That was nice of them. We're going to go in like this. Once again, red, or the power in, goes towards the motor side, black towards, let's say, these terminals. Now the fan that goes into fan 1 is going to come out of fan 1 on the, maybe come out of fan 1 on this board. This will be the other fan. And once again, we're going to turn the connector the way it's going to go in. Positive on your right, negative on your left. And that's going to go into the next connector there. Just like that. And then this one will be the case fan that will come from back here eventually. So all of that is there. Now the only other thing we have in our bundle coming from our our carriage is our extruder motor, which is an extremely long cable. So we will be shortening that one definitely. And once again, our motors are X, Y, Z1, Z2 for this third driver, E, and then the spare driver, which will be E1, which we're going to use for the secondary Z motor. So this is going to go between these two capacitors right here. And the connector, yes, goes this way. Now what we can also look at is just to make sure that the pinouts are the same here, meaning this way to this way, it should be 2B, 1B, 1A, 2A. And on the new board, it's A2, A1, B1, B2. So it's 100% the opposite pinout. So we are probably going to have to change the direction on every single one of our motors because I am not going to repin each and every motor. That's just not going to be in the cards tonight. So that was the E. The next one is going to be that secondary Z motor. This is coming from the right-hand Z motor, which we are going to bring in here and install in the furthest socket. So this will be on the E1 driver stick. Okay. And then the other one's going to be this closer Z motor. We're going to see, we're not going to have enough to kind of route it that way. But if we route it down and through our little notch that we have here, we should be able to bring it around and get that installed right there. At least I'm pretty sure. Well, that might actually make it. Didn't think it was going to, but it might actually make it. There we go. Next would be our Y motor, which is the one over on the right-hand side. My plan is going to be to try and bring the majority of these up and out of the way, up and around here. Especially since I have cable for days. And then once again, I will come in here and clean all of this up a little bit later down the road. Most likely off stream, just because I will be cutting a lot of these wires shorter and recrimping and doing all that. It's just going to be a lot easier to do that when I'm not sitting here on a stream. But just like that, I probably should have, well, no. So we've got everything off of our SKR board and onto this board. The only thing we'll have left to do now is do our display. And wow, I'm not sure if Ducky's coming back from this. Hey, Triclaw, welcome on in. Ram online. So I'm not sure if we can pull this one out and salvage it or not. We'll see if we can get Ducky to come back to life. Oh, well, Ducky lives. Ducky lives. We'll set Ducky over there to supervise. And I should have thought about this because if memory serves me right, the connector for this cable is right here, and it comes out the side, not the top. Which means I'm going to have to pull this board again to be able just to install this on the board so that we can connect up our display. So that stinks. Let me move a couple of things around here. That's going to be our display, a new display. And this is the BTT TFT35 SPI. So the nice thing on this is you have the SPI, the flat ribbon connector, but you've also, I believe this is an X8. I'll have to double check in the manual, but I believe this is a XH connector. So this entire pin out is mimicked right here, except this is a 10 pin and this is a 9 pin. The 10 pin connector adds this top pin, this IO whatever pin is added on the 10 pin connector. So, yep. So this will be the display that we'll install. And like I said, I'm going to have to pull this board to be able to get to that mounting lug again, which I'll say, darn it, darn it, darn it, darn it. And the other thing I need to do is this jumper right here next to our USB plug has to come off because you put that jumper on to power it from the USB. So we have to take that off since we're not going to be powering it via the USB. And then this connector over here is the one that we're going to have to plug our cable into. There we go. And once again, the cable comes in from the side. So that's the issue we're dealing with. And does the cable go up or does the cable go down? This is your motor voltage selection. Do not need diag jumpers. Or, I'm sorry, you do. If you're using sensorless homing, then you need to add some jumpers on there. We're not using sensorless homing. Installing the CM4 or the CB1 board. We will need this when we go to plug in our BLTouch. We are not using the auto off relay or the power supply. We don't have any RGB for this yet. We may add some later, you never know. It's filament runout sensor, LCD screen wiring. Be the standard LCD screen. Do you show? There's the 40-pin GPIO. Okay, so DSI and CSI wiring. So this would be if you're installing a camera, it goes on the right-hand side. The DSI for the display would go on the left side of our CB1 board, but that's if we were using a standard display. This is a specific SPI display that uses this smaller connector down at the bottom. There's an ADXL. Believe it or not, I have one of those kits. We won't need to work with one of those. And they do not show that actual wiring here. How about on this ClipperScreen? This is the Manta itself. Big Tree Tech. Repos. Bear with me, folks. I'm going to look for the SPI screen documentation to see which way the cable goes in. It looks like we will need to do some things in the software on the actual, we'll say, the boot environment variables to make everything work. Seriously. Well, I guess I'm just going to look at the connector that's on the display. It looks like it goes down. So I believe the connectors, so the shiny connector pads, are going to go down towards the board. So we're going to insert that in, hopefully. Maybe. There we go. Insert that in and then push the plastic retainer clip back down. I'm going to flip it forward, actually. So it's a rotate connector here. We're going to give it a little tug, make sure that it's in there nicely. Now, what we're going to do is we're going to take the other end and we're going to fish it up through this slot. And pull it through. Maybe. Fish it up through the slot. There we go. And there is a little bit of a divot in the print so that we can get this back where it needs to be. Hopefully. Whoops. And that does not appear to be fully lined up yet. Go. Oh, cable's in the way. Pull cable out, and it goes in nicely and printed. We are screwing this into plastic, so make sure that you don't try and ugga-dugga the heck out of this. You're just trying to get it to bite and hold in the plastic. Okay, and once again, we're going to pull our wires around, try and make them a little bit nicer in here. We'll add some zip ties up in here a little bit later and make it even prettier. Now our DSI display, once again, the pins are going to go down towards the circuit board. And while I'm thinking of it, let's go ahead and run it through the back plate. So pins down towards the bottom, push that tight, and it should be good, nice and tight there. And that's how our back is going to sit on now. And we've got a front panel and a back panel. So we'll add some screws into this, and I don't know, there's no screws in the box with the screen, and I don't know what screws it actually called for. I'm going to assume some M3, probably M3 by 10. Yep. We'll throw 1 or 2 in these. And once again, this is going to just self-tap in there. And you'll see there's 4 holes here. That's what will mount it to that other mount plate, which I'll install at another time. Just going to make sure that we've got access to everything, we can see everything, and we'll be able to see if our display works, if we need to do any adjustments to the display. So everything is wired up except for the main power. And once again, we're going to need to have power to both the board, so to both the board and the motors. So that's something to also think of, is we need to make sure that we add power to both the board and the motors when we go to do this. So it's either make jumpers or we'll need to add another set of wiring to come in here. I did not think about that before I started doing all this. And probably the easiest way to do that is going to be with just do some Legos temporarily for now. Because once again, the plan will be to ultimately redo all the wiring. So all the wiring is nice and there's no issues with any wiring. So we need this, and I need it into a box that's under a bunch of other stuff, which is almost a given these days for me. Change that thought, because that thought would have involved using 14 gauge wire, and that is way, way overkill for an Ender 3. So we've got some 18 gauge silicone wire in here. We'll use our standard of blue and white that we like to use. By the way, folks, I've got this purple here. This is the, actually here, let me switch over here, maybe. Micro SD card was in the adapter. Okay. So this is the purple that I am currently printing parts in. This is the Sparta 3D PC ABS. So this is the purple that we're printing in for the LDO motors parts. And that's what's going on the Voron. Oh, the Voron that everything broke free and has been printing garbage probably the whole stream. That stinks. So I have been having a little bit of issues with this. So we've done some spaghetti lately with this Sparta filament. The first set of parts came off beautifully, no issues, but the last few have been popping off in dramatic fashion, and I do not know why. We're printing with a bed temp of 110 and a filament temp of 280 though. So, yeah. All right, and we really only need to do pigtails kind of out and about here, so we don't need really long jumpers for this. And if you haven't been following along, yeah, I've got different color wire here, and I'm not going to sit here and go like, oh, well, I need to go and buy more red and black so I can just use red and black. Nope. I use, like in this case, I'm using white hot and blue is cold, right? So that's how I'm doing these little jumpers here. So white is hot, blue is cold. Because we ran out of red and blue, or red and black a long time ago. We're using some 18 gauge silicone wire. And like I said, we're just going to do some short jumpers and Dewago connectors so that we can get this board back up and running. White hot, blue's not. That's one way to do it. I always think about blue being ice cold. Okay. Oh, there it is. It's like I was missing something. This is 18 gauge. And once again, this is going to be just temporary, just so we can get it up and running again. And then I will, of course, redo it off stream to make proper and appropriate home runs back to the power supply, because this power supply can support multiple 24 volt connections. Meaning it's got the lugs for more than just one connection. Okay. The good news is I'm just running into one or two things that aren't uh, I'll spit it out here in a second. I'm running into just like one piece that's not that's failing, so I'm able to continue to move on and just take a note, and I'll create a separate file to go back and do all the prints that failed. So I'll let that bed cool down for a little bit, and then I will move those parts over, and then we will continue on with getting another print going. And we're using 18 gauge, which will be our red connectors. And this is 18 gauge. Probably 16 would be a little bit better, but I just noticed I don't have any more 16 gauge wire, and I'm not going to use 14 gauge. Like I said, that's just way overkill. So 18 gauge should be perfectly fine. There's our initial pigtail for our blue. We'll do another one for our whites. Get those connected up, and we'll be good. I'm doing bare wire into the Wagos, and then ferrules going into the controller board here. And don't worry, this wire, when I go through and redo this properly, this wire will not get tossed away. It will be used in other projects, because I do have several other projects that are electronics related, not 3D printers per se, but I will have the ability to reuse this wire other places. Time to crash and do it all over again. All right, Chewy. Thank you for the lurk. Have a good night. Enjoy it. Oh, yeah. Yeah, like for power, I'll use down to 18. But once I go from power, and normally DC, or actually AC can be 18. DC can get to 18. I've seen 20 go into tool heads and stuff like that. But yeah, I try and make sure that I'm not going to burn my house down. My wife kind of likes it when I do that. And I mean, it's one thing if you're intentionally just prototyping stuff. It's another when you're actually having to go in and sorry, real fast. If you're going in to like do permanent wiring, do it right. Don't do it jank. I mean, doing different colors is one thing as long as you've marked them or you do things to make it obvious. But yeah, just be safe, folks. All right, so we said white was hot, which means it's red. So we'll put the red wire in here. And I didn't think that was going to go. So these with the ferrules will not fit. So I'm going to have to cut the ferrules off, which I'm fine doing. I can always, I will use these other places, or like I said, I'm going to redo all of this wiring anyhow to include these. So that's there. We'll bring these two in. And then bring those two in. Okay, and what do we have here as far as pinout for this? Back to our browser window view. Go back up to our pinout. Okay, DCN, we've got power towards the motor side of the board. And same thing with the motor power. So heated beds over here. DCN, so it's going to be ground then hot. These is going to go there. This one over here is the one for the motors, and the high voltage is towards the top. So we'll bring that over here. With a little tug test. So our two hot wires are plugged in. That figures. And it'll bug me, so Move that out of the way and plug that in a second. Too hot, these are too cold. Trying to keep all of my wires kind of organized and keep wires from going in and out of each other. And of course, it's just so much fun. The one blue wire goes over here between these others. Good tug test. The other blue wire will come over here next to this one for our high voltage for the motors. Well, I haven't loosened yet. So test on that one. The two in the middle here, one of those is going to be my hotend wires, which we still hadn't run yet. We'll get those and run those through there. The nice thing is for our hotend is we really don't care in what orientation they are, just they're plugged into the right one. So hotend 0 would be the closest to me set of the two. So we'll go ahead and undo those. The tug, the other one in. There we go. Hey, Shrapnel Warning, how are you doing? Yeah, the Flying Bear Reborn 2 was actually a bigger printer than I expected it to be, but it prints pretty darn good. It's for a sub $400 printer for that size, it's pretty good. And like I said, it's $375 stock, $390 if you add the couple of additions like the PEI sheet and the automatic bed level sensor, which I would highly recommend both of those. And at that point, you're $390 shipped to the US. That's not a bad price. Not a bad price. Okay, this is for another project. Let me put that there, that there. We'll have the lid and the mount for that. The other thing that we still need to run is we need to mount, whoops, and do our BLTouch. So I'm going to bring you guys back up here. Back up here. Yeah, so we're going to need to do some BLTouchery. Let me try and organize a couple of things real fast. Grab some coffee, because we always have to have coffee. Yeah, shrapnel. It's been a pretty nice little printer. It's a good little build, fun little build. We also got to remember to put our SD card back in the slot over here. We've got our new there. We've got this. Our ducky is going to sit over here and keep an eye on things. We're going to do a BLTouch. I'm just going to move this over so that we have access to our BLTouch mounts a little bit easier. We need to open this up. Really without opening myself up in the process. We talked about this before. If you're going to get a BLTouch, make sure it's coming from ANSI Labs. Make sure it's a genuine BLTouch. If you're going to go with CR Touch, get a CR Touch. If you're going to go with the BQ one, get the BQ one. You don't want a third-party knockoff that's going to cause you some problems down the road. And I am literally going to get this stuck in there before I forget, because I will forget. I'm just going to set this right in there for now. And of course, this is going to go in right behind where that foot is. Make life so much easier. There we go. It's in, and it's a good place where it's not going to get hit, damaged, or yanked on. Yeah, whichever one you're going to get, make sure you get the real deal, Holyfield, and everything's good. I'm not going to pull these out. I am going to pull this out, and we're just going to grab the mount. I'm going to need the mount and some of the mounting hardware, most likely. First, to get to the screws, I'm going to have to go through everything in here. Screw, nut, probably washer and washer. I don't need any of the other connectors. They give you all the connectors that you would need to repen this out. However, well, not however, but the majority of ways. If you're using a JST or a DuPont connector, you should have all the connectors that you need here. If you use whatever comes or is required for use of a duet board, your duet board is going to come with a ton of connectors. So Irish coffee. You're having a breakdown, Mod Light. It's a printer. If you need to, walk away, relax. Don't ever do wiring when you're annoyed. Ask me how I know. And we're going to install this, and it's going to be installed underneath. And I'm not sure. What I'm going to try and do is figure out real fast if I've got enough room for the wire to come around that back side, and I think I do. So once again, I do have a wire, and this wire here came off of an Ender 5. So it's going to be plenty long enough for this installation. What I need to try and do is figure out if I can get it properly around behind the motor and the printed part and then attached. And if I can't, or if I don't feel like if it's too tight, which I feel like that's now too tight now that I jammed it in there, I'm going to pull it back out, and I'm just going to mount this with the cable on the outside edge. So that's how I will mount that. Which will make getting to that cable and any future work so much easier anyhow. So, but we're going to install this, hopefully using their hardware. So we're going to need a washer. And I normally do these with the screws coming down from the top. I know some people do it other ways, coming up from the bottom. 6 one, half a dozen the other. However you feel good doing it, that's the way you do it. We'll get that there. We'll line up our holes, and then we'll need to put on our nuts. Sometimes easier said than done. One started, get the other side started. Sorry, I'm going to probably get my big head in the way. Hey, Pete, how are you doing, friend? All right, so we got that in. That's fairly tight. And when you install one of these, you need to be a certain, certain height from your tool head. So from your nozzle. And I'm going to make sure this is a mount for the light, not for the Biqu H2S, what have you, I believe. So hopefully we get the right distance. If not, we'll have to do some adjusting. This is where I'm going to need a couple of rulers. Luckily, I have a couple rulers. Mark 1 eyeball says we're about 6 millimeters from the nozzle to our non-deployed tip. Let's go over to Fancy Labs and the BLTouch. This is most likely going to be a 3-1. I didn't even bother checking. I'm pretty sure it's a genuine 3-1 because it was the latest version. Need electronics, that's what you do as a part-time gig? Yeah. I don't know why this monitor is now starting to like go on and off on its own. I don't need the history. I need the how to install. Well, let's see, BLTouch 3.1 manual. That, and then there we go. Voltage, yada, yada, yada. Works with a bunch of different stuff. Specifications. And that's what we wanted right there. So between the nozzle and the tip of the BLTouch, you need to have anywhere from a 2.3 to a 4.3 gap. Installing it the way I did, which is hanging it from the underside, and then I'm just taking this and we'll say eyeballing straight and level, right? We're going to eyeball straight and level and take a measurement. And I am measuring about 5 or 6 millimeters. So I need to make up some space. So what I need to do is unscrew these, add a, just an M3 nut on the other side of it, and we should be good. So what I'll do is loosen these up, take the nuts back off, mount the nuts on there, then put the BLTouch on, and then add new nuts and that should fill our gap and drop us down. Heck, for that matter, we can probably put 2 nuts on there. Because each one of these is only getting us I guess it gets us 2 millimeters. We'll, you know what? I have a feeling those are actually M2, not M3 screws. Good news is I still have some M2 nuts, I believe. How much you want to bet those are M2 by 5 screws? That's okay, because we can swap these out and do M3 screws all day long. Double check. Yep, those are M2 5s. But it's compatible with M3 screws, so we'll just put these over in our, or put these back in the package. We'll grab some M3 hardware. Three by 16. Sorry, folks. RAM, have. If you want to do CAN, I can definitely help you with CAN. Or you can just review one of my several videos on CAN and doing my CAN installation. It's quite fun. So we're just going to take some M3 button heads. We're going to quadruple check that those go in the holes, which they do. We're just going to put those straight in at the top. We shouldn't need a washer, but we can throw one on there. Make sure that we're matched up the way we were before. So we'll have a washer, our screw. We're going to go ahead and add a screw or a washer and a nut to the bottom of these screws as it stands. And what that's going to do is provide us an initial spacer, because, well, we like spacers, even though I'm wearing my my other Ivan Miranda shirt today. Number 2, Rapido, Big 3 Tech, Nomi. So my Trident has the Nomi CAN bus, but I don't have a Rapido 2 on that. And the Rapido 2, if it's a Rapido 2 ultra high flow, you know, you could do a, whatchamacallit, you can do a, words sometimes are elusive. You could do a PT1000, which adds another layer of complexity in it. But did you do tap? All right, one side. Let's try to do the other. It's one of those times when it would be immensely easier to install this on the bench before it's installed on the printer, because trying to get your fingers all up in here and twisting a nut on a screw that's right next to wires is kind of a pain in the butt. Probably make it easier if I screwed it from the bottom to the top. So let's actually do that, because yeah, let's do that. We just dropped a black nut on a black tabletop. I see it. So the plan will be to come in from underneath. So we'll mount this directly underneath. We'll add our spacer in the form of a nut and a washer. And that'll give us our space underneath. And then at the top, we'll be able to add like a lock nut, which will prevent it from coming off. And this will give us access to everything. So we've got our nut. We're actually going to add 2 washers on each side as a spacer, and maybe that will give us about a 3 to 4 millimeter drop, which will get us a little bit more into that range that we need for our gap. Washer on top, lock nut. Awesome, my light, so it's working. Nice. Good job, my light. Tinker with it enough and you'll figure it out, right? We're going to tighten this down on there. Preferably you'd want to use a little M3 wrench, but that's good. We're nice and solid mount. Let's now take a look again. Let's see if we can use our little rulers and see if we're between the 2.3 and 4.3 millimeters in the gap there. And yes, we're going to be good. So now the other thing that we're going to need to do, now the BLTouch, since we're not using inductive, since we're using a BLTouch, we're good with whatever surface we use. We do want to put a magnet on here. We do want to put a flex build plate on here. So we'll be good there. The last thing I'm going to do is I just want to double check this wire color against the color in the package, and just make sure that all the colors are lined up right. The slightly different colors, but we're good. Black, white. So I at least know what order to put these in. So when we come over to the other side, that's going to be the critical thing, is just making sure that the 5 wires go into the same way. So we're going to come back over here to our BLTouch wiring guide. There we go. We're going to go white, black, which we do. And then, yes, everything right in order. And everything will be in the right order on my little pigtail here. So that's what I was trying to make sure and find out. We can now plug this in. Make sure you're plugging it in the right orientation so you don't damage any of your pins. Like that. And then we'll bring this up and we'll eventually loop this all the way in and around. I'm just going to throw a couple of zip ties on it right now. Maybe. Partly because we're starting to get long in the day and I just want to try and get this moving again. So one there. Throw one here. Fan will turn backwards if you wire it in backwards. Yep. All right, just like everything else, we're just going to bring this loosely through our wire channel. Bring it up here and make sure that we plug this into the right spot according to our wiring diagram. And that's going to be the one, yes. And a vertical cable right here between our, this way, while everything else is going that way. We'll turn this around. We've got our nice long dangly spaghetti wires over here. We've got our display. That over there, that over there. This will go in the garbage. This will go over here. I'm just going to tidy up a little bit and we're going to apply some power. Which means we're going to need this. That out of the way. Okay. Think we're good. What's everybody else think? You think we're good enough to hit the on off switch? On off switch. Wow, Luke. Okay. No magic smoke. No magic smoke. No magic smoke. No magic smoke. Our BLTouch did its little initial routine. We do have something. I just got flashes on the network drive. We have lights on the board. Oh, that's right. I had installed ClipperScreen, but there are some changes that we need to make. Let's see if we come up. We're going to be at a different IP address. We're at a different IP address that is not coming up. Well, let me rephrase that. It's not that it's not coming up. It's I don't know what the IP address is. So I'm going to jump on my router real fast and find said IP address. Okay. Alrighty, so let's come over here, go here, say properties, switch to the browser view. Hey, look at that. We've got an interface and it says BTT CB1, which this is a Big Tree Tech CB1 module. So that is good. We've got that going for us. So we know what the IP address is, which is 224. Now, in our instructions, it tells us that we need to go into the board env.txt file on that board and uncomment a line to enable the display and possibly add in a couple of other bits of information. So we're going to go into PuTTY. In fact, let me just do this. We'll go into PuTTY. I'm going to ask for a login. In this case, it is Biqu and Biqu because that's the default login for a CB1. And hold on, let me see what's going on in chat. You need to swap pin positions. A push pin can depress the tab on the connector. Yeah, the screen's a washout right now because there's nothing displaying. It's just the backlight. So give me a minute to work on that. Yeah, level head, steady hand, definitely. I bought me a used Cisco router switch and they're port 1 and port 2 on the back. Do you happen to know what it is? I do not, but if you get me the actual model number Modlite, I will find out. Time to name the printer, it is EnderXY for right now. Puff the Purple Dragon, or the Purple Dragon, that's true. I do not have Purple Dragon yet. I had Purple Haze. Purple Haze has found a new home over at Evil Diesel's house, aka Dragon Den Site B. Hey, Aaron F. Geared, how are you doing? Yeah, if you send DM me with that information, Modlite, since I work for Cisco, I can either find it out or find somebody that can tell me. So we're in our CB1 And we're going to need to go into the boot env file. So let's cd to /boot and just do an ls to see what's there. And we see the board environment.txt file is what we're looking for. So nano, which is our editor, board env.txt, hit enter, and that will open up the file. And we're going to scroll down for the overlays TFT35 SPI. And we'll uncomment that. So that is right there. We just uncommented that. Now I'm going to come back over here. And I think there was some other information that possibly needed to be done. Oh, maybe not. Maybe it was just that one piece. I thought there was more. So we'll do a Control X, Y to save, and enter to save it with that name. And it's telling me to go #, permission denied. So we'll say X, we'll say no, and we'll enter out. And we'll do this again with a sudo command in front of it, because we are in the root boot directory. Hey, Subsector, welcome on in. Thank you for the resubscribe for 6 months. Wowzers, thank you, thank you. So we have been doing a lot tonight. It's been a Modapalooza. So we just came down and uncommented that line again. We're going to do a Control X, Y, enter. It'll now let us. We'll do a sudo reboot now, and that will cause it to do a reboot. And if we're lucky, we will see on the screen when it goes into a reboot, and see now we have, whoops. No. We're in the browser window. We're now seeing the big tree text symbol, although it's upside down. Grr. And the easy way to solve that would be to flip the board in the housing, or just flip the entire housing for now. But I believe the Manta was designed to be over here, so it's just changing the screws and stuff. But as you can see, I'll have to bring you guys in a little bit closer here. Bing, bada, boom. We now have a ClipperScreen that's not very much in focus. So we're going to play this game of, do we get closer? Do we get farther away? I mean, it's in focus for me. I mean, it's not, this is an actual focus issue. So let's find the focal length. Yeah, backlighting does make it hard for the camera, but still. Kind of jank that it's, okay, but anyhow, it's there. Let's see if we can, well, that was awesome. I didn't do anything. Oh, yeah, we're going to do something real fast because I just realized I never peeled off the sticker. So trying to do a touchscreen with a sticker still on it probably not going to work out too well. And since we got to open the case or take the back off, we'll just flip the screen around. That way we don't have to try and figure out any, like, hey, let's go and run this command, that command, and the other command to finally get the screen to flip around. We'll take a couple of screws that we put in the back out. We'll pop the screen out. We'll pull this. So pull. Look at that. We'll go back. Uh-oh. So it looks like our touch either is way too sensitive or not sensitive at all. So we're going to have to play around with some things. No biggie. Let's get our case back, or our display back in the case. Okay, we'll try and do the back again. We're still not getting touch. So something is still not right. I thought there was more than just that one piece that we needed to do. I am running the latest image, so it's past 2.2.3. Change the board env.text. We did. Yep. Okay, so for whatever reason, it's not giving me my touch screen area is very sensitive, and I don't have, there we go. So I don't use the pointy end, use the round end. So I'm going to just say temperature, PLA, and things start heating up. So that works. We'll click cool down, which should be cooling things down. Yep, things are cooling back down. Okay, so let's go over to our mainsail. And we want to look at our machine parameters again. So printer.config. And the reason we need to do this is because, well, we didn't have our BLTouch set up before. So we need to scroll down through here. Oh, you're going to set up a PBX? Okay. So the other thing is we still have a display type in here for the standard graphics display. We're not going to need that anymore, so we can just comment that stuff out or leave it. It shouldn't throw any errors. Right, so we commented that out. Our steppers and everything. Now we said we probably will need to change the direction of our stepper motors. So let's move this over here and we'll test that out here in a couple of minutes after we do these other changes. We still don't have a filament switch. Extruder 1, you'll see here, and let me actually make this full display. Hey, Maker Viking, welcome on in. So you'll notice here that for Extruder 1, I did put in a comment that says used for right Z motor, and this part is all commented out. You'll see PB7, PB6, PB4. You'll also see up here that there is a Z1 stepper right defined, which is listed as motor 5 using PB7, 6, and 4. So I am using the same UART pins and all that good stuff from that motor. So I'm just leaving this here for clarity and with a note. We do have another filament sensor that we can use for something else down the road if we wanted to. I did pull over the PID heated information that we did before on the other board. Our fans are set up appropriately. Probing section. So the BLTouch, we will need to uncomment this information. And we'll need to set up some stuff. So the sensor pin being PA6, control pin being PA7. This should be the same. Oh. No. There we go. So we're going to come up here and double check our pin out. So for our BLTouch, ground, 5 volt, PA7, and PA6. So those should be correct. Oh yeah, no problem. Trust me, I buy old and antiquated stuff myself. Oh, apparently the battery on my mouse is about to go. That's lovely. I'll plug that in. Port 1 and port 2 are the 2 ports you're looking for, okay? Oh damn, I'm gonna have to actually find the... Oh, there's a USB-C. I'm gonna have to find a power cord. Give me 1 second. It works. That's the right one. Plug that in there. Plug in a power dongle, and that way it can start recharging while I'm doing this. So the connector should be right, so that'll be good. Now the other thing that we can do, or what we need to do, is because we're going to be using the BLTouch, one, we need to do our offsets. And for our offsets, we're just going to measure. So the X offset is 53 millimeters, but it's on the right side, so it'll be a positive offset. So in other words, the probe is to the right of the X, 53 millimeters. Okay, the Y offset, that actually looks like it's right in line. It might be a millimeter behind, but we'll leave it at 0. And then the Z offset is how high it is. And we'll set that. Well, no, let me think about that real fast. And by think about that, I mean, let's go over to Death Dragon, which is running a BLTouch. And check its probing section. Yeah, so the Z offset will get blanked out, and it'll get blanked out with the probe calibrates. So we'll hold off on that for now. Speed, samples, retry. We're just going to copy that. And add it in here. Okay. We've got our safety home set up. We've got our bed meshes set up and unchecked. So men is 10 by 10. Max we have set for 190 and 220. Yeah, we'll double check that. We should be good there. Grab a couple of other parameters here. Since we basically have just a very generic one. Probably 5.5 is fine for this size of bed. Yeah, we missed a few streams. Been sleeping nights, yeah. Yeah. So we've got our BLTouch set up. We've got our Z-Safe Home set up. We've got our bed mesh set up. I think we've got a good setting there. All right, did my keyboard just stop working for whatever reason? We've got bed screws adjust. The other thing that we need to do is if we're going to use our BLTouch for the probe, then we don't need the Z Endstop, right? So our Z Endstop is identified under our first Z motor. And you'll see here where we commented it out. We comment out the Endstop pin and the position Endstop, and we add the Endstop pin as a probe Z virtual Endstop. Right? And we do this because we're going to run a BLTouch. We're going to come back here and go up to our Z motor, and it's going to be our first Z motor, which is the left one. And we've got an Endstop pin and the Endstop position. We're going to make both of those commented out, which, like I said, would be great if my keyboard didn't stop working for whatever reason. Like, what the hell? That's weird. Like, I don't know why all of a sudden my keyboard would stop working. Mouse is working just fine. Keyboard goes off of the same oh, that's interesting. So if I was okay. So we've got to do a couple of things to enable the BLTouch. One of which is to turn these things off, and then to add a couple of other lines. So what we're doing here is we're telling it that the Endstop pin is the probe Z virtual Endstop. Oops, we got an ad in progress. Let me hold up for those that aren't. Yep. We're just going to hold off 1 second until the ad's over, which it's almost done. And everyone's back. Okay. So in order to use our BLTouch as an Endstop and as a probe, we need to set the Z Endstop as a virtual or a probe virtual Endstop. What that does is it tells it not to look at the Z. So technically we plugged in a Z Endstop here and we don't need it. And in fact, it may cause us issues if it's plugged in. So I just pulled it and unplugged it, which you probably shouldn't do while it's live and active. But that just made the Z Endstop go off, right? Or unplugged. Now there's probably a way that you can run both. And you can use the Z Endstop to set your initial bed. And then I've never done anything like that. You do that sometimes on a Voron so that you're locating the bed, and then you use the inductive probe to actually probe and set the actual height for your Endstop. I just always use the probe for that. So I always use the probe for the Z Endstop and the for bed meshing and all that good stuff. So we've got our BLTouch set up. We've got our offsets updated. And these are the offsets for the actual Z-axis. The Z offset here of 3, it's not going to matter. We'll fix that. For now, I'll even make that 0. That will get changed because just like we did Z Endstop calibrate, we're going to do Z probe calibrate. So take that out and clean that up. We should be good. We did the Z Endstop. We uncommented and set the parameters for BLTouch. We set the additional parameters for our bed mesh. We commented out the stuff about the legacy display. Physically unplug the Z Endstop. I think we're good, guys and gals. Was there anything else you guys think we missed and we need to address? I don't think so. Let's do a save and restart. The other thing would be the direction of our motors and whether or not our motors are going in the right direction. So we're going to scroll back up here so we can get our stepper buzz command. There we go. So what we're going to do is we're going to do a stepper buzz, and it should move positive and then negative. So it should move to the right and then to the left. If it doesn't, then we have an issue there and our motors are backwards. So we're just going to paste that in there. We're going to hit return. And it does look like okay. Well, we'll give it a try. Let's see if we home X in the right direction. So the bed just moved in the wrong direction. X moved in the right direction. Y should home towards the front. So that's good. But our bed is, our Z-axis is moving in the wrong direction. So we need to fix that before we go any further. So we'll come into our printer config. We'll come down to our stepper Z motor. And for our direction pin, we're just going to remove the exclamation point. And we have to do the same thing for our other stepper. Otherwise, they're going to go in opposite directions, and that would be bad. Ooh, the other thing that we can do, and I just noticed that I don't think it's in here. Got a bed mesh. We have bed screws. We don't need this either. In fact, this is duplicative. Oh, we got two display sections. We'll fix that. What we need that we don't have, and I just jumped back over to Death Dragon real fast. Actually, I'm thinking of something. Give me 1 second, folks. I was going to look for Z tilt, but what I'm going to do is I'm going to pull up the old config for my Ender 3 that I gave over to Evil Diesel, because I had dual Z there, I believe, and I believe I had, at least I had dual Z, but apparently I still didn't have Z tilt adjust on that one either. Well, that sucks. Oh well. So what I need is a basic Z tilt adjust. So I'm going to scroll down here on Death Dragon, and we've got a Z tilt section here. For right now, I'm just going to copy that. And add that over here in our probing section. And we'll do some changes. So About what we need to do is find how far back from the front the lead screws are. So, and it's really the center of the lead screw. And that's about 120. So we've only got 2 points to probe, and our Y is going to be at 120. And then our X, and I believe trying to think. So the Z position is where your lead screw is, or in this case, where the pivot point is. In this case, it's a lead screw, so we're going to be most likely a negative number. So we're going to be negative 27. So this first spot is the location of the pivot point, right? So we're going to call this left lead screw. And the other side is going to be the same thing. Maybe 3. The 23, so that's going to be added on to the full bed movement, which is 220, right? 235. 235 and 23, 258. And we don't need the third point, so we'll delete this line. Sorry, let me put you back on full display so you might be able to see and read what I'm putting on here. And then same thing here. We're going to need just the 2 lines. So we'll get rid of that third one. And your first point does need to be, oofed, what did I just do? Okay, your first point does need to be on that line with Z positions. You can't drop it down and indent it. It does need to be there. So this first point, once again, our Y's are going to be at 120. Because we want it in line with the lead screws, right? And for the point, we need to take into account where our actual probe is. So on this one, my probe is to the left, so there's a negative offset. On this case, it's to the right with a positive offset. So I actually want to say like where the nozzle has to be in order for it to be able to probe. And since the probe is to the right of my nozzle, I can literally say put the nozzle at 5 and run a probe. It's going to actually, yeah, that'll work. And then on the right hand side, once again, our max is 235, so I need to take off the offset for our probe. I'm glad I just looked there because that X offset is not correct. It is definitely not 3. It would be 53. So 235 minus 53 actually will, so 230 minus 53, public math. Where's my calculator at? So we do want to give it a buffer, so let's go 230 minus the 53 offset. So we want to put in 177 because that is where the nozzle is going to be. Okay. Now we'll do a save and restart. So it picks up all of our changes. Hey, Bionic, how are you doing? So once again, we've been playing and tinkering because we cannot leave well enough alone and we like to try and figure out how to break things. So what we've been working on is making some modifications to the EnderXY. We had it working. It's been printing off Toys for Tots penguins for a while, you know, having a grand old time. You'll see there's still no print bed on there. It's no big deal. But what we have done is we've installed a new board, and we took out the, initially we took out the Creality board and put in the BTT SKR Mini E3 V3. And that was a stock upgrade for this printer. We also changed out the Creality hot end for an H2 V2S Lite because the kit came with a V2S, a Biqu H2 V2S, and I went with the light version on this. So what we've done is we've added a BLTouch, which means we've disconnected our Z Endstop and we're going to use the BLTouch to probe the bed. We've swapped out the BTT Mini or SKR Mini E3 V3 for a BTT Manta E3EZ board. So since this has a Manta board, it means it has a CB1 module on it, so which acts as the Raspberry Pi. We're using the EZ drivers, which are the kind of like the stick drivers that look like DIMM RAM modules. So we've got 5 of those now, which means each one of our Z motors is on a different stepper. So we can now do Z tilt adjust, which is what we just set up. Okay. So we've done a motherboard swap. We've added a BLTouch. We've added a full ClipperScreen capable SPI screen. So we now got ClipperScreen set up. And now we're just making some added adjustments. Our X and Y were moving in the right direction. Our Z was not. So when I say home X now, the Z should drop down In fact, let's do a, so I'm going to do a stepper buzz on stepper Z. This, the left side, should go up, down, up, down, up, down 10 times. Or actually, I'm sorry, down, up, because it's positive, up. So positive is down because it's the bed that's moving. So it's now moving in the right direction. And now I'm going to do Z1, whoops, Z1, and that should be the right motor. And it is going down then up. So positive, negative, positive, negative. So everything should be moving in the right way now. The one other thing is I want to check my Endstops. So X is open. Now if I press it manually, it's triggered. Now I'm going to trigger the Y. It's triggered. But it says Z Endstop is open. But my probe is not deployed. So interesting. Well, we're going to go ahead and say home all. And if our BLTouch does not deploy for whatever reason, I'll just hit the emergency stop real fast. So let's give this a shot. Bed goes down. X, Y, and that worked. And once again, you see that I'm doing this with no build surface up here. That's just so I don't gouge anything. But what I'm going to do now is we need to do the Z offset. But normally what we did the last time when we were using our physical Z was we did a Z underscore Endstop underscore calibrate. Well, we don't have a Z Endstop anymore because we're using a virtual Z, which is the probe. So now what we're going to do is we're going to type in a command, and that is, actually, before we do that, we're going to do one other. We're going to do probe accuracy, and that's going to just test the repeatability and the accuracy of the BLTouch. Okay, and you'll see the maximum was 0.0025. And so our standard deviation is 0.000750. I don't know about you guys, but that sounds like a pretty good standard deviation, right? I was going to say, I was going to say push plastic, but have you even pushed any chocolate out of your cocoa press yet? So we did a probe accuracy, and it's coming out pretty accurate. Now what we're going to do is we're going to do a probe underscore calibrate. And what that's going to do is it's going to probe that point, and then it's going to move the nozzle over there, and it's going to probe again. Now here's the other thing to consider. This is the center of my bed. I'm probing over here, and this is, well, center of the bed. This is where it's probing, and this is where it's going to base all future probe points off of. So since this is a 53 millimeter distance, what I want to do before I do this probe calibrate is come back into my machine, into my printer config, and I'm going to scroll down here and I'm going to adjust my safe Z home. So currently I had it set to 115 by 115, which is roughly the center of the bed, right? Hey Steve Builds, how are you doing? Welcome on in. So since we have a 53 millimeter positive offset, what I'm going to do is I'm going to move this point on a on the x-axis 53 millimeters less, and that's going to put my BLTouch roughly right where the nozzle is at when it does its probe. So 115 minus 53, public math, let's grab the calculator. Would be 62. So we're going to change this to 62, 115. Save and restart. Hope you're doing well tonight, Steve Builds. We're having fun and playing around. So we've got the EnderXY here, which was printing great. We've been printing off cute little penguins for Toys for Tots, right? Cute little penguins, owlgwins, whatever. And we had our first layer good, but the standard Ender build plate is just, it's way too sticky, right? It just, I'm bending it as much as I can, and it's really not breaking free. It's that build tack surface on a almost like a fiberglass or Garolite bottom. So we're going to put a magnet and a double-sided PEI sheet on here, but right now I'm just working with the plain bed because this is a BLTouch. I don't need it to be conductive or anything like that. And we're just setting it up and running through to get things set up. But we've added the BLTouch. We are rocking our Biqu H2 V2S Lite extruder. So it's kind of like the Volcano, but it uses an M4 nozzle instead of an M6 Volcano nozzle. And so this is a 0.6 hardened steel version that I will swap into here. Right now it's just rocking a 0.4 copper version. We updated the motherboard. The kit came with a BTT SKR Mini E3 V3. We've put in a BTT Manta E3EZ board. So it's got the 5-stepper drivers, so we're running an independent driver for each of the Z motors. We've unplugged the Z Endstop, and we'll take that off in a minute or later, since we're using the BLTouch. We've added the BTT TFT35 SPI display, so we're using that little SPI connector versus a DSI connector for this. Everything's on 2209s. Yeah, it's running a CB1 now instead of an external Pi. And we just got everything set up. So let's do a home. We home to the front left, and then it goes to the middle, and the middle should be where the roughly in the middle should be where the thingamajigger is. The BLTouch. Words, I tell you. So we just did our initial home. Let's go ahead and try our Z-tilt adjust and see if it throws any errors. We probably don't need it to be a 30 point or 30 millimeter drop there. So we'll change that later to something like, I don't know, 5 or 8. But once again, what this is doing is probing both sides and then making minute adjustments to both sides to bring them closer together. Right? So our tolerance between them was 1.028, and we're looking for a tolerance of 0.0075. So I can probably make that bed travel a little bit faster too. Hi, Steve. Who builds? Yep. Yeah, the pancake steppers can be quiet, especially when you pair them up with a 2209, a 2208, 2209, 2225 driver. So 2 Z-tilt adjust runs, and we probed at 0.00125 tolerance. So we're pretty level between the two Z screws now, right? Now, quite honestly, I could just put the Ender, one of these back on it and call it done for now. But I really am going to put we're going to put a PEI sheet on it, because I got a couple of PEI sheets that were going to go on the Ender wires, but now I realize one's got an Ultra stick and the other one's got a Creality textured plate on it. So that works for now. And I believe this is just the actual PEI sheet. So good thing I had a spare magnet. We'll go ahead and install our magnet. So let's drop this down a bit. Yeah, PEI for sure, definitely. Like I said, I mean, when I first had my Ender, I really liked that, that BuildTak surface. But after going to PEI, yeah, no, that BuildTak just like grabs way too much. I'm just going to get this lined up in the front again. And then get it started on the back. reach under and pull this plate, pull the covering forward some more. Working the air bubbles out as I go. Normally I would try and do that and let it sit for a couple of days or a day or two. Yeah, not going to happen. There we go. That there. When it puddles like that and it doesn't roll off, you're pretty level. Just saying. I'll take this down and wash it with dish soap later on. So now we'll go ahead and do a home. So my standard, I'll say print start macro, we'll do a home, a Z-tilt adjust, or quad gantry level, and then another home, right? And that just makes sure that my build plate is even and that I'm rehomed and I'm good. So we're going to do a home, a Z-tilt adjust, because I just put a new surface on here. Sorry. And then we'll do another home, and then we'll do the probe calibrate. And when we go to do the probe calibrate, we'll need our little measuring piece of paper. So we did our home. We'll do a Z tilt. So Steve Builds, when's OC Maker Fair? It wasn't this past weekend, it's this coming weekend, right? Or was it this last weekend? Upcoming, coming up this Saturday. Okay, good. And you're going to be at the, you're going to go to that one? I'm assuming, since that one's pretty close to you. You're in the, I'll say mid-California area, right? I don't want to like try and dox you any. All right. Wait to me, rods and lead screws. Time to build something new. Oh wait, we've got a few builds already. All right, so we Z-tilt adjusted, and our range is 0.00625. Kind of feel like I can add another 0 into my tolerance count there or something. Oh, DaVinci, the drop game might not work on this particular screen for some reason. You'll be manning the boron booth? Yeah, that's what I thought. I thought you were in Sacramento. I was stationed out at McClellan for a few years. Okay, so now that we've done our probe, Z-tilt adjust and probe again, we're going to do a not probe accuracy, but a probe calibrate. And it's going to do another homing sequence. And then you will see it move. Ah, there we go. Like, where's my little sticky? There's my sticky. Or there's a sticky that'll work. So it'll move over so that the nozzle is where it just probed at. And that's what we want. Oh, you got your sticker? Yeah. So now what we're going to do is the same standard. We've got a pop-up window that comes up here. And we're just going to start dropping it down until we get close. And then you run out of room because you don't have enough negative Z offset range. So, well, that's fun. Let's come back into our machine. V-stepper motor, position men only lets us go to -2. We'll add -8 there. The other thing I want to do is scroll down here just a little bit. Five and 0 Z-hop. We're going to drop our Z-hop here down a bit. You want it high enough that you don't mess up your bed. But once you do this the first time, and if you've gotten your bed semi-flat to start with, you know, unless you sit here and really make it wonky, which you won't be able to do with these hard points, I mean, you're just trying to show off. You don't need that. The other thing we're going to do is drop that down, or actually, no, we want to keep that there. Z-hop speed is 5. Okay. Do a save restart. And we'll go through our ritual again. Sweet. So we did that. Z-tilt. We actually have a lot of, I'll say, maker type events out in the California region near you, right, Steve Builds? Yeah, I thought I changed that, but apparently I didn't change it in the right spot. Yeah, Steve has some really nice builds, switch wire or anything else. He does some really nice builds. The the upgrade of your V0 to a V02, rocking the duet was pretty awesome. I need to go back and rewatch that since I'm getting ready to do a V02 build. Yeah, Open Sauce in July, Rockland last weekend, OC Maker Fair this weekend. Yeah. Okay, so home, Z-tilt home. Now we're going to go back to probe calibrate. Okay, and we're just going to start lowering this down until we get close. All right, that is contact, so we'll go back up. We'll go down to the next one. We're getting close. All right, so that's pretty much there. So we'll go back positive, then we just keep moving ourselves to the left and going in smaller and smaller increments. Until we really like how good that is. Well, there we go. I really like that. So we'll say accept. And now it has a new Z offset of 2.879. We'll save config. And it now has that offset set. Oh, hey, Big Jano, with a raid of a party of 20. Holy cow. Welcome on in, Big Jano. Yeah, I saw your note that you were going to start streaming again. That's awesome. Hey, Chris, how's it going? Manor Mutant. Pez Liz coming back in because she was in multiple streams. Imagine that. Ram Online as well. Imagine that. Da Vinci as well. Man, everybody's over there. Hey, K2, how's it going? How's it going? We're up to no good again. We've been doing the Modapalooza. So we started off with this machine running a BTT SKR Mini E3 V3, and it would normally have a Biqu H2 V2S extruder hot end combo. I didn't want to leave that well enough alone, so when we built it, I actually got a V2 or an H2 V2S Lite, which is kind of like a Volcano, only using an M4 nozzle. So other than that, everything else was stock, right? So this stream, after we've been printing with it for a while, doing a bunch of Toys for Tots prints all day, every day, I was like, okay, time for the next stage. So the next stage in this case was switching the motherboard over to a BTT Manta E3EZ. So this is an all-in-one board that has a CB1 module on it that acts as the host computer. And it uses the EZ stepper drivers, which are the stick stepper drivers that plug in kind of like a DEM or a memory module. So we've got that installed. We also added a BTT 3.5-inch SPI display. So this is the BTT TFT SPI. It plugs in with a slightly different cable through the SPI connector. So it uses SPI for the screen and the CB1's I2C pins for the touch functionality. You can plug this in through a Raspberry Pi through the DSI connector, but it will not have touch capability. So there you have it. So we do have full touch capability here. We can move around on the screen, sometimes having to use something smaller than a big meat mitt finger to, come on, go back. Right, so we can move around and do things. We don't have any files loaded up on this at the moment. So we're good to go, right? We just set our offset. We can go ahead and add our filament back in here, and we'll go ahead and get this loaded. I am going to clean up the wires. Darn it. I wanted to make, before I cut any wires, since I was doing a board swap, I wanted to make sure that the wires that I had would all fit before doing a board swap. And once again, this is really nice. There's a lever there. You just flip the lever and you now have a clear filament path all the way down to the nozzle. So when your filament isn't like fully bent out of shape, you just take it all the way down and then you flip your lever back. Whoops. Yeah, I don't have any Dunkin' Munchkins today. I did not make a Dunkin' run, and Mrs. Dragon is not here. So it was just me. All right, and for some reason, we may have to just do a manual. Oh, there we go. We're there. Yay! So now we can come down here on our screen, go to temperature. We're just going to go ahead and tell it to heat up to PLA. And once it's warmed up, we'll make some adjustments. Meanwhile, let's go over to the move. We want to move 25 millimeters, and we'll tell Z in the positive direction, which should drop our bed down. Of course, it's going to tell me to home the axis. Why not? Home. Yep. No munchkins and just home coffee. So I'm a Dunkin' dude because the Dunkin' is the closest option to me. So I used to do Starbucks all the time, but now it just, yeah. Oh no, you're missing all the screws for your enclosure. You probably used them for something else already. No, Wolfman Crab Arms. She's literally out of town. She's back in Colorado again. And then she's going to leave Colorado and go to New Orleans for a conference. With her mom. They're going to go from New Orleans up to Atlanta so her mom can visit a friend, and then she'll fly home from there. So, yeah, well, Big Jano, if you ever go to Earth, you'll go to a Dunkin' because there's like 6 right around the venue. And at least the Aberdeen Diner, which is where we went for breakfast, yeah, their coffee was basically colored burnt water. It was the weakest coffee I've ever had. Hot tinted water. Yep, exactly, Chris. Yep. So, folks, if you could do me a favor, I'm seeing a lot of people showing up in the chat, and you've got a highlighted box around you that tells me that you're still a raider from Big Jano's stream. If you would be so kind, at the bottom left of your screen, right underneath your viewing window, there should be an icon, a digital dragon. You can just click on that. What that'll do is bring you fully into my stream. So it helps with the metrics and stuff like that. I'd appreciate that. All right, so we've made our tolerance on the home. So I do want to just go back, and I do want to drop the Z down a bit. So I can then do a filament load, which goes into the extrude menu, and you can do a load. And of course it's going to bark because the ClipperScreen command is looking for a specific, it's looking for load underscore filament. And I change it to be filament load and filament unload just because I like my macros to, I don't know. They're in, like print start and print end. So they're right next to each other. If you go with start print and end print, they're completely different places. Okay, so apparently it does not like the way I cut that tip for whatever reason. Let's try and cut it again and see if we can get it to actually load the filament. Now it's getting down through the gears. There we go. I'm feeling like it's got a jam or something. Oh, you know what? The extruder motor's going backwards. The one thing that we didn't check yet. So what we were noticing is when we changed the board out, we did have to double check, and there were a couple of pins that we had to flip between the boards. And then also we're go ahead and get this back to temp. Yeah, and I just didn't check that didn't even bother to look and go, hey, is the extruder motor in the right direction? It was not. Hey, look at that. There's filament coming out by hand. Now let's see if we can get filament to come out by command. There we go. If you have the motor going in the right direction, it works. Oh, so K2 is bringing you coffee too. I got you. You put them in an acro mills drawer. Well, there you go. You put them away. All right, so We are pushing plastic. Now what we need to do is get a file over to it because, well, we don't have a file to it yet. And we're on 224. So let's set something up real fast. Orca. The whale of a slicer. EnderXY, let's update the that. PLA, yes, yes. Let's grab a file. Any file will do. I say that and then I go, ooh, let's find something cool to print. Absolutely. Let's just do the simple and easy way. We'll do an orca tube. I haven't done one of those yet. We'll get that uploaded and going. Brought a coffee maker on the road. Yeah, most of them have coffee makers. Well, some hotels have coffee makers in the room, and I would just bring my own pods. But quite honestly, when I'm on the road, dude, I'll drink any coffee, gas station coffee, because it reduces the number of stops. You know, you stop to fill up gas, you stop for new coffee. Now this is running the standard macro, and I think I took out the Z-tilt adjust stuff in the macro. Let me check real fast. Well, I definitely took out the bed meshing. Let's put that back in. Now, I need to throw a couple of things in there. Come over to this scene so you guys can see the print and see me as I tinker around over here, because I'm gonna tinker around and try and grab macros from elsewhere. That was funky. You bear with me 1 second here. Well, what did it just... SD card file reset, move exceed maximum extrusion. Okay. Line purge should be good. Printer config. And now I have to make a change and try and figure out what it is. There we go. There we go. Save and close that. In my macros, let's start. We do a G28. Z. Is it Z hyphen tilt or Z dash tilt? Or Z underscore tilt? I think it's Z underscore. I think it's Z underscore tilt. Okay, so let's try that again. Yeah, with Steve Builds, it's either in one of his build trays as he's working on it, and then he goes to clean up. Like, I'm sure he's probably like me. At the end of the stream, you start putting everything back in its proper spot so you can find it again. You probably went, well, I need to do something with these, and you rebend them. And by the way, for those of you that are just stopping in, so this is the Sparta 3D, and this is a Sparkle PC ABS that we're using for the red framed Boron 0.2 LDO Boron 0.2 S1 kit. So we're going to use this, which is the Sparkle Purple Mist PCABS, and we're going to use the PCABS fluorescent Sparkle Fluorescent Red as the secondary accent color. Yeah, I keep moving a pile over here, and then when I'm done streaming, it comes over here where my laptop is, when my laptop goes back to the desk. And it's just this pile that keeps going around, and it's like, I just need to do something with that pile. Like, I've got a Dragonfly and a Dragon High Flow that I bought new heat brakes for because the heat brakes were clogged. But while I was waiting for the heat brakes to come in, I unclogged the heat brakes in them. So it's like, okay, I need to put some of that stuff away so that I can stop just moving it around. That will be an eventually thing. Yeah, no kidding, Wolfman Crab. Like, I'm seriously thinking, like, okay, I need to add like 6 more rows of rep racks somewhere because I've got 12 spools here, 5 spools there on the ground, 2, 4, another 5 spools there, a 5 kilo spool there. There's like another 8 in the closet on the floor. Don't even get me started what's on this bench underneath it. I've just got stuff everywhere. Like right now, I've got 5 printers downstairs in the dining room going because Miss Dragon's not home. RAM Online, are you talking about using Klipper to do an IDEX? Or 2 tools at the same time with their own macro at a change? Like if it's set up as an IDEX, you can do that. Steve Bill should be able to help you out with that. Him and Eddie did the Tridex. Yeah, so a Tridex would work in like mirror mode, or you can use them as like literally two different colors going into the same print. Eddie and his contributors did the Tridex. I just built it. Okay. Well, I couldn't do the Tridex without you designing the Trident, so. Gotcha. So right now we're doing our initial prime line. Because we have camp running and we've got line purge running. Okay, and that looks like we're a little bit too high. So what I probably should have done was just something a little bit bigger. So let me cancel this. And we're just going to do my standard of 120 millimeter cube. Because that makes it a little bit easier to dial in a layer height. So what I normally do is, like what I did here, this is a 120 by 120 by 0.6, so it's 3 layers. So it's all solid infill at that point. So you'll just scale to and uncheck the uniform. 120 in the X, 120 in the Y, 0.6 for the Z. We'll slice that, but before we get going anywhere, I will actually, as soon as my screen comes back to me, I will drop it down 0.1 and save it just to get a head start on it. Yeah, they can do 2 prints in mirror mode, or you can do 1 print and just use it as, use both nozzles in that print. Normally you would use two dissimilar materials so that like you'd have a support material in one and the other material for the actual print in the other. You need software to think you have 2 tools and run their own macro. Okay. I'm not sure. Not sure. But yeah, we've got so talking about printer builds, Wolfman Crab Arms, we've got a LVO Motors V0S1, or excuse me, V0.2 S1 kit that we're going to print. It's basically like a commission build. I'm building it and then sending it back to KB-3D, and it's for another maker in the community, a maker in need. And then I've got a box of parts that's supposed to be a 2.4 build for Chewy. And I still need to open that up and inventory that box of parts, which means I'm probably going to throw some paper down in the living room on the hardwood floor and just lay everything out, inventory what's there, figure out what else I need, and then talk to Chewy on some pricing and get some stuff on order through KB-3D. And once all, that should all get in here before I'm done with the 02 build. And then we'll build another 2.4 for Chewy. And by the time I'm done there, I should have a black box kit here. And we will be doing a black box printer. Correct, Mod Light. And you wanted me to do a collab with a 3D printed telescope. Not sure yet how that's going to work. We'll definitely have to chat about that through Discord and get that squared away on what you need from me for that build. If you need me to print all the parts, I can print all the parts. Yep. Yeah. Yeah, I figured Chris would be able to find it too, since he's got the black box. Though it's not using Clipper, it's using Duet. But there's nothing that says it can't use Clipper either. Okay, so we started off, we already dropped it 0.1 millimeter. But this, being a larger box will give us an opportunity to make the necessary changes on the fly. It seems like that the back corners are off. We never did a bed mesh, did we? Has this been doing a bed mesh? It should. Did we not do a bed mesh? Macros. Print start. Oh, damn it, man. So that's going to be an issue. Save and close. UI settings. Give me a cancel print button. Cancel the print. It's looking fairly good. So looking at this, I mean, other than we need to get a bed mesh going because it was all bad over here, I'm seeing some ripples. So we're probably a little bit too far down now. Whoops. Right, so we'll probably want to pull it up a little bit. Actually, may still actually be just a tad bit too high because I am seeing the layer. There we go. Then the other test I kind of have is just pulling it straight apart. And that's not coming apart, which means that's nicely welded. Yeah, I think we're a little bit too low now. So let's... Oh, that. We'll save config, which is going to do a restart, which is good. So now it'll pick up the bed mesh. So we'll actually do a bed mesh. Like, I don't know why we'd want to do one of those. And I'm just going to heat some things back up. Bed mesh is for the fearful. Yeah, we always do a bed mesh. Yeah, the Tridex should have tap on both heads now. In fact, you blew one of them, right, and had to replace it? So yeah, we've got a couple of things for the Voron as well. So this is going to go on Fey Dragon, but we got a set of carbon fiber gantry parts from Chaotic Labs. Big Tree Tech gave these to me at Earth. So these will go on the 2.4. I'm debating whether I want to get the full carbon rod kit or not when I do it. Just because if I'm going to take it all apart, I might as well do it at one time. And the Fey Dragon, the 2.4 right here, has a printed tap, Rev 8 printed tap. Okay. And what I'm going to put on there is a CNC Voron Tap V2. So this one's good for 5 or 24 volts. So I should be able to unplug the tap that's in there, plug this in with no issues. And yeah, and I'll gain a little bit of depth back in that print. Or in the, yeah, and I'll get like 3 or 4 millimeters of depth back on the tool head. All right, so we did a home, Z-tilt and a home. We're going to go ahead and run a bed mesh just to see about where we're at. Say what? Oh, goodness gracious. So the bed mesh commands are just not right. So the bed mesh, would you throw move out of range, -43, 10, and 5. The -43. I have it set to 10, move out of range, -43. So it's taken into account the offset for this. Okay, it's wanting to probe where. So when it does the probe, it does that based on the probe itself, not where the nozzle is when it does the bed mesh, right? Which my X minimum then would be 53 for the bed mesh. Well, in this case, I'll say 55. And we'll say 230. Oops. 230, 230. Get my heaters going. We're just going to do a home, and then we'll do a bed mesh. Yeah, you definitely want to tension your belts, and there we go. Don't mind me. I'm just going to do a little surface prep while I'm waiting. Move out of range. Oh yeah, that's true. Ay, ay, ay. Eventually we'll get there, game. We're going to go full send this time. So what I was trying to do is just get a good bed mesh to see where things were at as far as all of my corners. It's still going to do a bed mesh now with this. Hopefully we'll get into a print as well, because that would be great. Be great, be great, be great. Yeah, I really like the look of this. You can't see the sparkles too much on screen, but this is a really pretty color. Okay. Yeah, now I know Steve Builds normally does it by feel, but I use that little app. What is it? The Sound Spectrum app on my phone. And that works out pretty well. It you know what you're really looking for is to make sure that your belts are the same tension, right? You want them both to be the same tension, especially in a CoreXY system. And same thing with your X and Y on a bed flinger. Cool. All right, folks, I'm going to have a seat real fast. So I think next week, not next week, next stream, so Thursday, we will do another giveaway. What are we going to give away? Well, we're going to give away the Biqu H2 V2S extruder that came with this kit, since we're using the light version of it. I have no need for this at this time. So on Thursday night, we will do another giveaway for this extruder hotend combo. I will make a post about it on Twitter as well to let all the peeps know. But yep, another one of these will be up for grabs. And yep. So it looks like, I don't know, guys, that bed is pretty fugly. Yeah, we're going to have to work on that. So I kind of think we need to do a bed screws adjust, huh? Let's do that real fast. We'll do a quick bed screws adjust because that is not working out too well. I didn't think we'd need to, but apparently I was wrong. All right, bed screws adjust. Whoops. Yeah. Yeah, that's good. It's always good to have crimp tools and especially JST connectors. All right, I think we're close. Yep, we're there. Yeah, apparently, yeah, that was some ugly, crazy, way off bed adjustment there. That was, but we're good. We should be good now. Now you just need to find a PT1000 heater that can fit your K1 Red Lizard. Okay? Oh, wow, I didn't realize it was 10:30. We've been at this for a little bit longer than I anticipated tonight. So speaking about that, any raid targets for the evening? Who could we possibly raid into? Tuesday night. Who all do we have out there? How about Britt? That's what I was thinking. Britt should be on. Ooh, and she's painting and printing. Yeah, we could definitely do that. Polymaker streaming, okay. Might break your cardinal rule and get one on AliExpress. Okay, Pezliz, are you going to be on Polymaker stream, Pezliz? Not a problem. My light definitely help anybody out. That's for certain. I will definitely help people out. But I will keep at this. We will get a decent print. I will post a picture of said decent print. Oh yeah, he needs to add periwinkle for you. Or just call it Pezwinkle. Or Pez with periwinkle. I will mod light. I might grab something to eat first. All right. So let me go ahead. Let's go over to Polymaker. Let's go harass Nick. Let me set up a raid. It's what? Polymaker underscore 3D. All right. Raid is initiated. Everybody, let's go on over. Let's give Polymaker a big raid. They really help out with the stream, or not the stream, with streamers and lots of events. Let's go show them how much we appreciate all they do for the community. Thank you all for hanging out with me so long tonight. We are going to get this printing nice again. I will throw you guys some pictures and love on this. Thanks everybody for coming in. Thank you, Big Jano, for the raid and bringing in your raiders. It's great to see you streaming again. Shout outs to everybody. I really need to get a couple of mods in here to do some shout outs for me. Thanks everybody. We'll see y'all on Thursday night. Yeah, I think we'll do one final night of chatting about this build. That'll let me get some other prints in the way, and we'll start the V02 build on Saturday with lots of good coffee and a great Saturday morning. Take care, Steve. Have a great one, everybody. Mod you. I'll mod you. I'll add you as a mod, Chris. Take care, everybody. Let's go over and raid Polymaker.